Hello friends, welcome back to my channel, and today I am going to talk about the mediation model in lavaan package again. So we are going to see one case, one database which I have already put it in the desktop. First the database has to be put in the RStudio. So let us do that. So it is simple. There is this one import data set. We can go here and it is a CSV file. So let us take this text one. We are going to browse it, and the name of the file is, I have to go to the desktop, and in the desktop I have mediation data. Let's see where it is. Yeah, here it is. Let me open this, select it. It is retrieving, and this is the code which is generated automatically by RStudio. I will copy it so that I don't have to do it again and again in case I run the file again later on. So the data has been retrieved, so I will import it from here. So this is our database. X is an independent variable, this one. M is a mediating variable, and Y is a dependent variable. Now let us open our script file and copy this particular command again. Also, I had told you before that all the libraries have to be downloaded once, which can be downloaded from here, from packages, and install. You can install any library once, and then you have to just call. So let me call the other libraries which we are going to use in this particular mediation model. So in this mediation model, I am going to talk about Sobel test, which is calculation of indirect effect. So another library which we are going to use, so let us not do anything here now. I have already installed. Okay. Another library is lavaan, which I am going to call upon. The next one which we are going to call is Semplot. Semplot, here it is. The other one which we want is library mediation. Here it is. In library FlexPlot. Now FlexPlot, you have to download it once, and I don't think so it can be downloaded from here. At least I could not do it. But if you go to this particular site, GitHub, and then you say that you want to download the FlexPlot, there is a command here. You can see it highlighted. You have to just copy and paste, and it will download. Once you have to do this. I've already done, so I'm not doing it. So I'm just calling for the FlexPlot, that is flexible plotting. It will help us to plot the mediation model before and after mediation of the variable. That I will tell you in the last. Now we have already called upon all these libraries. So it is a good practice if you write a comment, small comment, what you are doing, so that the person who sees this script is able to understand. So we'll put hash, we can write calling all relevant libraries. This is a command, it will not be read as a program by the R Studio. Then again can write database I can say that database selection then we are going to write model specification. Now we'll specify the model specification. Now we can write some object name like mod, small model MDL1, and then we can write like this. That means model, whatever we are defining, will go into this object by the name of MDL1. What is that? We'll start with inverted commas. As I told you in the first video, you can see my first video which is talking about this, about structure equation modeling. In that I've explained you the syntax a little bit. So this is our object MDL1. Now we will specify the model. So what is the model? What we are going to do now? You can see this particular file. It has X as independent, M as mediating variable, and Y as dependent variable. So what it is exactly? What we are going to do? Let us open one paint. So that I can explain you the model. Okay, now so we have one variable which is X, and it has impact on Y, which is a dependent variable. But it may be that one more variable is there, which is mediating variable, which in our file it is M, which is impacting again Y. So what is Sobel's indirect effect? So this is the path which we can name it as A, and this is another path which we can name it as B, and this one XY we can name it as C. We are only focusing on A and B right now because it is an indirect effect, and the C is a direct effect. Total of indirect and direct effect, sorry, total of indirect and direct effect is called as total effect. So indirect effect plus direct effect is total effect. Right now we are focusing on indirect, that is A and B, the path coefficients we will multiply, and if this coefficient multiplication is significant, we can say that our model is correct and M is definitely mediating between X and Y. So A multiplied by B should be, the indirect effect should be significant. That we have to prove in the Sobel's effect. So let us do that. This is our file. X and M and Y all are capitals. So let me go back to my file where we are working. We will define the model. So X, capital X, what is that? M is being predicted by X. First we write, yeah, M is being predicted by X. So M is predicted by, sorry, M is predicted by X, and second is Y is predicted by M. Y is predicted by M. Then what else? Then we have to define the path. First one is A. XM is A. MY is B. XM is A. XM is A. So we will write small a asterisk. So we have defined A path, and here it is B path. It can be A, B, C, D, whatever you want. But it should be consistent. Whatever you write here, you should use it in the future also, same. Don't change it. Okay, now we have done that. Let me put some space so that it looks good. Let me increase this. Oops. Yeah. Now we have to define our indirect effect, say IND1. We just name some random name and we put it like this, equal to like a face with eyes. And indirect effect is nothing but A multiplied by B. This is multiplication, this one is asterisk, so don't get confused, please. A into B is the indirect effect. So this is our model specification, and this model has been saved, will be saved in MDL1 object. So that's all about this specification. See please, this is inverted commas, it has to come in inverted commas. It is telling the R that this all is part of one model. So we will go ahead with other things. Let us now fit the model. So we'll fit the model and we will form the object fit1, which will be like this again. Then we write structure equation model function. Now when we are writing this, don't think that is difficult to learn. This is very simple. Sem m is there, yes. Then we write the model name. I remember like this, sem m. M means first you write the model name, model object. MDL1 is our model object. MDL1 is our model object, that's it. And then in model there is D. From D I think of database. So data is equal to, we will write data is equal to mediation data. That is the name of the file. Name of the file is mediation data. So this is how we fit the model. Apart from that, we have to do other things. We have to find the, because this is mediation, and we have to do bootstrapping. I will tell you the reason later, but we have to do bootstrapping. And then we have to find the standard error or sampling error, not sampling error. Yeah, sampling error is if randomly if I take out samples there will be some deviation between them. That is the error between samples. That we'll find SE equal to, how we are going to find, randomly by bootstrapping. So we will put boot. This is our method for standard error. Then we will mention how many bootstrap, how many randomly we will pick the samples. Bootstrap equal to 100. It should be 5000, but for the sake of saving time I'm putting 100. Bootstrap is equal to 100 and it will be fitted in the object fit1. So next step will be summarize. Not summarize, sorry, summary. And then what we will summarize, double M is there. I'm keeping it in the memory like this, double M. So first obviously fit1 will be there, summarize fit1, and then we are going to talk about double M means fit measures, fit dot measures equal to true. We can make it capital T. Summary fit1 and then fit dot measures is true, and also we are going, because this is double M, we can write r square equal to true. So summary fit1 and fit dot measures is equal to T, and r square is also T. T is true. It should be done. We need it. So we will summarize the fit model. That's all about. And also, okay, let us run this once so that we can understand whether it's working properly or is there any error. Let me clear this and let me run this. Yes. So let us see if there is any issues there. Okay. Let me little bit increase this also. It's too much. Now some time will be there. Let us wait. Again, let me run it once. It is calling the libraries. Yeah, now it's working. Maybe I have not pressed the button properly that time, last time. Let me go to this particular plots. So we want the model to be fitted and then bootstrapped randomly for finding the sampling error. And after finding the sampling error, we want to get the summary of that. Okay, there is some error fit1 not found. Okay, let us see if fit1 is not found. Why? Oh, I'm sorry, there is wrong. It should be like this. Yes. So again, Control A, run. Now it is working. I think so. There was one error. I used the wrong indicator. I mean less than it should be, and I put greater than. So we have 1.5 which has come. MDL1 has come here in the environment. We can see there. That's good. If any error is, now it is doing bootstrapping. See, it has waiting here. After bootstrap, summary will come if there is no error. It should be 5000. Again, I'm telling you, this is 100 only I put. Okay, there is something. Unused argument fit dot measures. Unused argument. Okay. Oh, measure spelling is wrong. MEAR. Measures. MEAS. Yeah, it has come. Fit measures. Fit dot measures. It's okay. Now let me clear this once. Let me clear this once so that memory is little less used. That's all about. And then let me select. Now it should work because I've already debugged the program. Now I've run it. It has come. If there is error, it will take time. If there is no error, that means it will work. If it's taking more time, then that means some issue has there, some error will come. But mostly it is easy to find the mistakes because the comment will come, like I found 2 mistakes in 2 seconds. Not a very big issue. Now summary has come. There is no error, that means. Let me increase this and show you. Now we have to see that model is correct or not. That I have done it in the last fitting of the model. I did it in the last video in structure equation modeling in R. That video you can see. But here I think the model is already fit as per my knowledge. I've already worked on that. So chi-square, again, p-value chi-square is sample size sensitive, but it is already okay. It is more than 0.05. So chi-square we want it to be more than 0.05, not less. It should be more than 0.05. So that means that model fits data. Data is fitting the model and model is fitting the data. So it is match. That is good for us. Then we can see this CFI and TLI should be more than 0.9. So it is 1. That is good news for us. So fitting the model, this is already fit is there, but in the last video in structure equation modeling I fitted the model. You can see that if you want to know how to fit the model. And then RMSEA should be it is 0.00 less than 0.08. It should be less than 0.08. SRMR should be less than 0.08. They are all less than 0.08. So it is a good fit as of now. Regressions are significant, less than 0.05. P-value you can see here. That is good for us. Now what we are interested is indirect effect, which we named it IND1. It is significant. That is good news for us. It is significant. That means we can say that there is a mediation effect is there by the variable m. So x and y are being mediated by m. We can say that. But in the Sobel test and indirect effect, there is an assumption that there should be the indirect effect should have normal distribution. Now to check that is a little challenge. I'm not saying it cannot be, but it's like it's little difficult. So what we can do is we can check the confidence intervals of indirect effect. So let me see that. 1 second. It's not showing. So let us put one more small command. parameter estimates for fit 1. So let me see if it works. Control enter. Yes, it has worked. So now this is the confidence interval we are looking at. Everything is there, but we are already only interested in AB confidence interval. So in this is the lower limit of confidence interval at 95% confidence level, and this is the upper limit. In this limit, 0 should not come. In this interval, 0 should not come. If 0 is coming, there is a problem. That means there can be an issue. But in this, 0 is not there. So as this is positive, this is positive. If any one of us is negative and another is positive, 0 will come in that. That is not, then there is a problem. Then it is not proven. Because once we have checked this one also, to support this IND1 is significant because of the assumptions are there and we may not have met them. So to make sure that it is correct result, we take our confidence interval approach, and in that 0, if it is not there, then now 100% I can say that M is having a mediating effect between X and Y. So our research question is answered, and we can publish this in the research paper, or we can put the results in the thesis or dissertation. So this is what it is. Now some people are using other Baron-Canning approach also. What is that? In that, X should be having impact on Y. It should be significant. Then X should have significant impact on M. And then X and M, when they are regressing, this is third regression. First is XY, second is XM, third is XM on Y. When XM on Y is done, X to Y should have insignificant effect. In presence of M, X should have insignificant impact on Y. Either it will be insignificant or the effect will be very less. It will be reduced. If it is reduced, it is partial mediation. If it is 0, it is complete mediation. So this is how you can test this. Also we can do it in R, which I will make a video separately. That's not a problem, but one is enough. This one is okay for us as of now. So many approaches are there. So this is a good approach, and then we have done this, and we have proven our research. We have answered our research question. Research question was whether mediating effect is there of M on X over Y. So there is mediating effect. We have proven it through the Sobel test. And it's very, very simple, by the way. There is nothing in this particular. I can give you this file in the comments. Even the script I can give you. You can practice and you can easily do it. Only remember one thing: flex plot or mediation will not work if you don't do this work. This one. You have to do this one. You have to go to GitHub or you to go to Google and find out how to download flex plot. This is the command. You can copy from here also. You can type from here also by seeing it, and it will come. It will download directly. Once flex plot is downloaded once in your machine, then this process is not required. That's why I'm not doing it. You have to do it once and it will download. Flex plot will download as a library. Once it is done, you can call the library flex plot. You can call the library mediation. Now the thing is about flex plot and mediation. Why I'm talking so much? Because now we will graph it. What is mediation? Now mediation is X has an impact on Y first. There is a slope. Now when there is a M is there. One is XY. Another is when M is there. Slope will change. So with mediating variable and without mediating variable, slope will be different. And we can show this in a plot easily in R, which I liked about R. It has a good graphical capabilities. We can show it in a graph, the mediating effect, which is a very powerful thing if you want to publish a paper or you want to put it in dissertation. So how to do that? Let us go back and put one command. That's all. What is the command we can put? So we'll put mediation or mediate, I think so. I'm not sure. It happens. Mediate underscore plot. Yeah, mediate underscore plot. And then what we are mediating, what is the mediation? You know this. Where is our model? So how do we write this? Y is being mediated. Y is being predicted by X. As I told you, Y is predicted by X, but there is a mediation, so we write M plus X. So remember to write the mediating variable in the center. Obviously, Y, it's always in the center. Mediation X, M is in the center, Y is there. Yeah, same thing we have to write here. Y on X by the mediating, and in between there is a mediating variable. So can we plot it? Yes. Plus again, one thing I have to add, you have to mention the data, from where the data will come. Data is equal to, what is the name of the file? Mediation data. Mediation. Yes, it has come. Mediation data. Now I hope it will work. Control. Run or control enter, same thing. Can we do it? So magic will come. I hope so. Yeah. So something is coming, huh? See it. Magic is taking time. Oh, so joking. So now this is this slope, this one, black one, is before the mediation, and this blue one is after mediation. The difference is the mediation effect. X is the independent variable, Y is the dependent variable, and here M is plotted. So in the y-axis it is Y and M, and the x-axis independent variable is there. So this is what we can, beautifully we can see. We can export it easily, by the way. You can just click here, save as image, save as PDF. You can do whatever you want, and you can put it in your article or in your document, whatever document you're preparing. And this is a very good way of showing the mediation effect, and in the graph form, which I liked a lot in this particular R. So this is the file. Now I'm going to put the file script, the programming file, as well as the data for practice in the comments, or you can see it in the comments or in below the video. You will get it. And if you like the video, please subscribe, like, share about my channel, and please support me, and I'll be thankful to you, and I'm sure that I'll be able to help you further, because I am going to give you more of such kind of test statistics and research on R. So please subscribe, and you can get updates from me whatever I'm doing, and I'm sure that it will help you, and it will develop your interest in R. Thank you very much.